Alright, so Chapter 6 test review, just some word problems. So from the review section at the end of the chapter, I've pulled out all the word problems I could find. We'll go over those just to make sure we're getting some extra practice with the word problems. Alright, 17, a height problem. From a certain distance, the angle of elevation to the top of a building is 17 degrees. Here's my building. There's the ground. 17 degrees. At a point 50 meters closer. Alright, so I move 50 meters closer. And now my angle of elevation is 31 degrees. Approximate the height of the building. Alright, so to get there we're going to need to find this hypotenuse, and from that we could find the height of the building over here. And we can do this pretty easily with the law of sines. We know that this angle is going to be 149 degrees, 180 minus 31. And from there, we can subtract from 180, so we've got 166. So this angle here is 14 degrees. And so what we've got here is we've got 50 over the sine of 14 equals, let's go with the side we know, or we want to know, h over the sine of 17. And we'll plug that into the calculator. Let's see what we get. 50 divided by the sine of 14 times the sine of 17 is 60.43. So that's how far it is from the second point to the top. But we do want to find b. So from 31, now we're doing a sine problem. The sine of 31 degrees equals opposite b over the hypotenuse, 60.43. Cross multiply here, sine 31 times 60.43. And we get a height of 31.12 for our building. Feet. Second problem. Find the length of the side W of our parallelogram over here. Alright, well this is set up for law of cosines. If we did this, we would have 16 squared equals 12 squared plus W squared minus 212W cosine of 140. And so on this we've got a W squared and a W. We're going to have to do a quadratic. So let's see what we got here. 16 squared is 256. 144. W squared minus 2 times 12 times the cosine of 140. A negative times a negative plus 18.39 W. I'm going to move the 256 to the other side. 0 equals W squared plus 18.39 W minus 144 minus 256 is negative 112. And that looks like a quadratic formula problem to me. Let's see. Negative B plus or minus the square root of b squared minus 4ac all over 2a. And let's plug it in here. Negative 18.39. Let's actually do the determinant first. Underneath, 18.39 squared minus 4 times 1, negative 112. And square root that. So we've got negative 18.39 plus or minus 28.04 all over 2. Well, we're definitely not going to minus because W needs to be a positive answer. So let's get rid of the minus there. Put those together. And divide by 2, and we end up with 4.8 0.82 for W. Problem 3, 19. A tree stands on a hillside slope 28 from the horizontal, from a point 75 feet down the hill. So this distance from the tree to the bottom of the hill is 75. The angle of elevation to the top of the tree is 45 degrees. And they got the figure here. We could definitely draw this without the figure here. Do some practice with that. You might see that on a test of some sort. We want to find the height of the tree here. Alright, well, we want to find this oblique triangle here with the height of the tree. We know that this angle in here is 45 minus 28, which is 17 degrees. And we do know that this side length here is 75. And we do want to find another angle before we're ready to go. If this is 28 in here, 90 minus 28 is 62, which makes this side 118, this angle, which makes our last side 118 plus 17 is 135. Subtract that from 180, and we've got 45 degrees. And so we're ready to set this up and solve. 75 over the sine of 45 equals the height over the sine of 17. Cross multiply 75 divided by sine of 45 times sine of 17. 31.01 for our height of our tree. A river problem. A surveyor finds that the tree on the opposite side of a bank. Alright, so here's one side of the bank, here's the other side of the bank. Flowing due east. The river's flowing due east. Has a bearing of north 22, 30 degree east from a certain point. So here's our point. We're going to go north and then spin towards the east at 22.5 degrees. Remember 30 over 60 here. So in here, that angle is 22.5 degrees from a certain point, and a bearing of 15 degrees west from a point 400 feet downstream. So here, 400 feet. From north, we're going to spin 15 degrees west. So that angle in there is 15 degrees. Find the width of the river. So W is our width here. Couple ways we could go about doing this, but we do have a triangle here of 400. We know that our angles in here are 75, and our angle in here, 90 minus 22.5, would be 67.5. And with a side of 400, that's more than enough to find either of these sides. Let's find this diagonal here. And so D over sine of 67.5 equals 400 over, what's this angle in here? 180 minus 75 minus 67.5 is 37.5. So sine of 37.5. And let's solve for D here. 400 divided by the sine of 37.5 times the sine of 67.5 is 607.06 feet. And so then if we wanted to solve for W, W would be the adjacent side. So the cosine of 15 is going to be W over the sine, over the hypotenuse, which is 607.06. Cosine of 15 times 607. And we end up with 586.4 feet for the width of the river. The length of the diagonals of a parallelogram. diagonal 1, diagonal 2. D1 is 10, D2 is 16, so clearly my parallelogram not drawn to scale. Find the lengths of the sides of the parallelogram if the diagonals intersect at an angle of 28 degrees. So in here is going to be 28 degrees. Alright, so parallelograms, diagonals do bisect each other. So I'm gonna draw this triangle here. And so what we have there with an angle of 28 degrees, the side lengths are going to be 5 and 8, half of them. And so let's find the side length here. Side length 1, S1 squared, is going to be 8 squared plus 5 squared minus 2, 8, law of cosines here, 5 cosine of 28. Let's plug it into the calculator real quick. 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 28. And I get 18. Remember, we've got to square root that. So 4.28 for S1. 4.29 actually. For the first side length. And for the other one, it would be the exact same problem, except we would have this angle in here. And that angle is 180 minus 28, which is 152. So same problem, except for we swap in 152. And let's do it again. 8 squared plus 5 squared minus 2 times 5 times 8 times the cosine of 152. And I end up with 159. Square root it. And we get side 2, 12.63. Two side lengths of the parallelogram. The lengths of the diagonals of parallelogram are 30 and 40. Find the lengths of the sides of the parallelogram if the diagonals intersect at an angle of 34. Alright, this is pretty much the exact same problem here, so I won't go through it. All the steps, it's the same as 35. But suffice it to say, see if you can work through this one. The long side ends up being 33.5 on that one. 37. To approximate the length of a marsh, a surveyor walks 425 feet. It's all drawn in the diagram here. Turns 65 degrees and walks 300 meters to point C. Find the length of AC. This is law of cosines. 115 degrees inside. Our distance AC squared is going to be 425 squared plus 300 squared minus 2. 425, 300 times the cosine of 115. Plug that all in and you get a final answer on 37 of 615.1. Alright, navigation. One that we've had a little trouble with. Two planes leave an airport at approximately the same time. One is flying 425 miles per hour at a bearing of 355. Alright, so from north, we've spun around 90, 180, 270. That whole rotation there was 355 degrees. We know a full circle is 360, so this angle in here is going to be just 5 left. The other is flying 530 miles at a bearing of 67 degrees. So from that same spot, going this way at an angle of 67. Okay? And draw a figure that gives a visual representation of the situation and determine the distance between them after they have flown for 2 hours. Where there's our visual representation. We're flying at 425 miles an hour for 2 hours. That's 850. Let me keep the colors the same. 850 is our length here. And we were flying, not driving, flying at 530 miles an hour for 2 hours here, which is 1060. Let's connect the two here. We want to find this distance. And so luckily we've got our middle angle. And so we are ready to do law of cosines. X squared is 850 squared plus 1060 squared minus 2, 850, 1060. What's our angle that we're going to do the cosine of? 67 plus the 5, 72 degrees. Plug it all in and you're going to end up with a distance from each other of 1135.5. Alright, let's jump a bunch here and get into the force section. Forces with magnitudes of 85 and 50 pounds act on a single point. The angle between them is 15 degrees. And so we've got 50 pounds going this way, 85 going this way. The resultant is going to be the diagonal, which is the diagonal of a parallelogram made by adding these two vectors together. Alright, so let's describe that resultant force. So what we have here, and the 15's being split, but not necessarily in half here. We don't know that angle, but we do know this angle over here because two adjacent sides of a parallelogram add to 180, so this is 165. We want to find this distance in the middle. Law of cosines, we're ready to go. X squared equals 50 squared plus 85 squared minus 2, 50, 85 times the cosine of 165. Put those together and you get 5.6. Oh, sorry, no, that's the wrong one. Let me plug this in. 50 squared plus 85 squared minus 2 times 50 times 85 times the cosine of 165. And we get, oh, we got to do the square root, 133.92 is our resultant force.